Hey everybody, welcome to the Tampa Bay Data Engineering Group. And here I am again. This is Alex Merced, Senior Tech Evangelist for Dremio, here for this month's meetup. And basically, before we get started with the meetup, what I always like to do is put up this particular slide so that way if anyone wants to download the slides, they have access to this particular deck or any other decks that I've created. So again, just to give you a heads up, when you scan this QR code, it'll take you to a Google Drive folder where you'll find PDFs not only for this slide deck, but for other slide decks I have created. So again, I'll leave this up there for one more minute. But again, as you enter in, what I like to do is share this QR code so that we can download all the slides for this particular presentation, because I'll be sharing lots of QR codes and lots of fun images. So for those who want to catch those and have those in a nice PDF, scan this QR code. You'll have access to not only this deck, but all my other decks as well. Okay, so I'll leave that up there for like 10 more seconds. Cool. And let's go on with the show. Okay, hey everybody. Again, my name is Alex Merced, and you're listening to this presentation, which is called Dremio's Apache Iceberg Powered Reflections. Basically, the idea here is to understand sort of how this feature works. So this is a feature of the Dremio Lakehouse platform called Reflections that's used to kind of basically eliminate the need for materialized views, for cubes, for accelerating, query performance. But underneath the hood, it's powered by Apache Iceberg, and that's what I'm going to kind of delve into a little bit today. But again, a little bit about me. I am with Dremio, and again, as I mentioned, Dremio, the unified lakehouse platform for self-service analytics. Bottom line, we just make it easier to implement a data lakehouse by offering you sort of three categories of value. And those categories are unified analytics, where essentially we make it possible to sort of federate queries across different sources, allow you to connect to databases like Postgres and MySQL and others, allow you to connect to your data warehouses like Snowflake and Redshift, allow you to connect to your data lakes, whether they're on-prem or in the cloud, basically allow you to unify all your data sort of in one place with a semantic layer and lots of other features to help sort of really kind of create one unified place to access your data. On top of that, we have a very powerful SQL query engine with some of the industry-leading price performance. So essentially, you're not going to get queries done as fast for as cheap as you would with any other engine. It's one of our sort of really cool and best values. But basically, it's not only is it fast, which again also lower costs, but also has things like reflections, which we're going to be talking about today, and the ability to federate those queries across all your different data sources. And the final category of value that we bring to the table is lakehouse management, especially when you're implementing an Apache Iceberg-based data lakehouse. There's a lot of work, okay? Having to connect all your data sources, having to catalog your tables, maintain those tables. So Dremio brings a suite of features that are integrated into the platform that make it much easier to do this with a catalog that's currently powered by the open source project Nessie. So basically, this catalog not only works with Dremio, but can be connected to by Spark, Trino, and other tools that can connect to the catalog. But it offers you like catalog versioning, so branching and merging, and also built into this is automatic optimization of your tables. So automatically compacting your Iceberg tables, automatically expiring snapshots, just making basically having an Iceberg data lakehouse feel like you're just working with any other data warehouse platform day in and day out. And one of the beautiful things about Dremio is that it works connects to your sources, whether they're in the cloud or on-prem, allowing you to really truly unify your data for typical modern hybrid data lakehouses. But I'm a senior tech evangelist for Dremio, and I'm also one of the co-authors of a book known as Apache Iceberg, the Definitive Guide. So I spend a lot of time talking about Apache Iceberg, as you can tell. And this QR code here would allow you to get a free copy of this book. So basically allow you to get a free PDF of the entire final manuscript of the book. So if you're interested in learning more about Apache Iceberg, do scan this QR code and, well, learn more. Only a few more little announcements, but just of course, again, like I say, I'm always here to educate, entertain, and enlighten. I'm also the host of several podcasts, and you can find these podcasts on iTunes and Spotify and find all my social links at this URL right here. But with no further ado, let's get on to our featured presentation. Now, what we're talking about here is query acceleration. So bottom line is a lot of times query engines are going to be fast to a point. Okay, Dremio offers definitely one of the fastest query engines available. But there are still going to be points where you're dealing with data sets that are so large, queries that are so complex, and you're going to want to build things like BI and reports off those data sets, off those queries, that it may still not quite provide you the latency that you want. You don't necessarily want to have to flip a knob on your BI dashboard and have to wait 30 seconds or a couple minutes for that BI dashboard to refresh. You want kind of that instantaneous feedback. And this is where, in those cases where you're really pushing the limits of whatever, of particularly the Dremio engine, which again generally can handle quite a bit. When you hit those edges, reflections are going to be a feature that are going to help you quite a bit. But again, the issue you have is when you're querying those larger data sets, you're going to start seeing that it takes longer and longer to process the data. You're going to run into memory issues, okay? Because sometimes the data set's larger than the memory that you have across the nodes on your cluster. Okay, whether you're thinking of a Spark cluster, a Dremio cluster, or whatever massively parallel processing system you're using to process those queries. Group by aggregations take even longer because you're having to recalculate these calculations for each group after it's already kind of divided up all this data and then shuffling the data to get them into the right groups on the right nodes. Okay, so overall you end up with sort of these really long living queries sometimes. And there's different ways you can accelerate it. So the idea is like, how can I improve the performance of these queries? Well, a couple traditional ways of doing this is one, you could use an index. Okay, so indexes, basically the idea here is that you're just having some sort of other data structure, some other information about the information to be able to plan a scan more intelligently. So you could be like, okay, hey, it could be an index that says, hey, the data with this value is over here. Okay, the data with this value is over there, or some other type of variety of different types of indexes that basically capture some other type of information that allows us to understand the main piece of information, the table, much more intelligently. That works. Now, the only catch with indexes is that they have to be updated every time you write data. Okay, so basically it's going to add latency to your writes because not only do you have to update the table, but you got to make sure that the index is up to date with the table. You could do a materialization. So these are things like materialized views and cubes, where you create a physical copy of the data so that way you don't have to compute the whole query again. And that works, but a couple catches here is that oftentimes materializations, one, create a whole new namespace. So in this case, I'm in querying table A, and now there's a new name that's like table A underscore materialized. And if I query the wrong name, I'm still running the really slow query. So one, I have to be aware of these new names. Two, you have to kind of figure out how to update that materialization. Some systems do this automatically, but not all do. So you kind of have to figure that out. And yeah, I mean, those are the sort of the two major problems with materializations. Okay, and then oftentimes that materialization usually satisfies like one use case, but you might have many different sort of situations you're trying to solve for. So you end up creating lots and lots of materializations for different scenarios. And that just becomes a lot of names that your data analysts have to juggle to know, okay, query this version for this query this version for that query, and it just gets really messy. Okay, you could also do a results cache, okay? But you need to have logic, or you need to have some sort of way to make sure that, hey, you know what, if the underlying data has changed, to invalidate that cache so you don't use the results based on stale data. That works too. Okay, so all of these things are good ways to kind of speed up the results. But Dremio takes a pretty cool approach where it says, like, why choose one of these when you can just kind of do all of them? And essentially, Reflections is a mix of all of this, okay? It's essentially a mix of caching, a mix of indexes, and a mix of materialization, okay? Because basically what it does is that you take a table or a view that you want to accelerate. So I might have this one particular view of my data that I want to have run a little faster. And when I turn on Reflections, what it's creating is an iceberg table version of the data. So even if the underlying data is like a table in Postgres or a table in SQL Server or a table in Snowflake, the reflection is Iceberg. And because it's Iceberg, you get a couple different benefits. One, you're going to have the materialization, so you have the copy of so if it's a view, you're getting that nice physical copy of that subset of the data. But again, it's in Parquet files, so you're going to get all the benefits of Parquet with the row groups and the compression that allow you to scan those Parquet files even faster. But then, acting like an index, but Apache Iceberg metadata acts like kind of like an index. It provides all this information about the underlying data to not only scan the faster physical copy better, but to be able to scan it more intelligently, being able to do file pruning, eliminate files from your scan, be able to take advantage of partitioning. You can actually partition and sort these reflections. So basically, you're not just getting a copy of a subset of the data, like a materialization, you're also getting all this metadata that allows you to scan that materialization much more efficiently. Okay, and essentially together they kind of act as a relational cache to your data. So then what happens is that once you create this, it doesn't create a new name. So it doesn't become like table A materialized. Basically what happens is that the Dremio semantic layer tracks that you've created a reflection and knows, oh, based on this table or this view, you've created a reflection. And whenever that table or view is queried, it'll just substitute it. It'll just be like, okay, let me just swap that out. Okay, so this way the analyst doesn't have to really think about, okay, which version of the table do I need to query? Dremio does that. Okay, so you're getting the benefit of one, is less likely that the analyst is going to make a mistake of querying the wrong name and getting the wrong performance, which also generally means a more expensive query. And two, you're getting a nice hybrid of like indexing and materialization to get sort of this really nice resulting acceleration. So again, basically, as you use these, they're transparently substituted. So basically what happens is that I'm going to query the table or view. Okay, so my queries don't change. I don't have to suddenly update every query that I have. And so basically other people who've written queries against the same table are going to notice their performance benefit. So it's not me who may have, like, maybe I had one particular BI dashboard that I have on this. I put in a request for acceleration. I will benefit from it, but then everybody else who uses that table will also notice a improvement in performance without having to do anything or be aware that this was ever created. Because again, the Dremio query engine, it knows that these reflections are related to this table or view, will evaluate them, and you can create more than one. So you can create like a reflection that's partitioned or sorted a different way, another one that's partitioned and sorted in a different way, and then again Dremio will evaluate which is the smartest one to use for the particular query based on the predicates in your query. And the thing is that Dremio gives you a couple different types, two main types of reflections. So basically, they fall into two sort of categories. There are other types of reflections, and I'll give them a brief mention in a second, but there's raw reflections. Think of raw reflections as something you would use in place of a materialized views. So in a raw reflection essentially is making a materialization of the raw results, so the raw rows of data. So typically this is used because you want to materialize like a join that you have as a view, or maybe you have a view of your gold layer and you want to kind of materialize those views in your gold layer that are actually serving your BI dashboards and reports directly. I might do that. Aggregate reflection is going to be more replacing cubes, because what you're doing is you're materializing the aggregates. You're materializing, like for example, if I'm thinking of like a sales table, I might be saying, oh, I might declare a dimension of department and a measure of sales. And then it's like materializing like average sale by department, max sale by department, minimum sale by department. All that gets materialized into this aggregate reflection, which again is an iceberg table. So you get the benefit of the metadata that acts as an index and the physically optimized physical materialization in Parquet files that sit on your data lake. And you get the additional, well, I'll come back to that. But bottom line, you're getting that benefit. So again, I would do raw reflections when I want to materialize raw rows, and aggregate reflections when I want to materialize the aggregations to speed up a BI dashboard. And I can have both on the same table or view. And again, Dremio will determine which one's the right one for that particular query. So a BI dashboard that's working off the table might be routed to the aggregate reflection, while some sort of query on the data itself to get back some rows will be routed to like a raw reflection. Now, there are other reflections that are generally like, they're not ones that you really build. Like there's a snowflake reflection, which is just really more like if you model the data, if you create a snowflake schema in your semantic layer, Dremio will pick up on it and will optimize the reflections based on that. So it's not really something that you like actively do. It's just something like a bonus you get if you model your data in a particular way. And then external reflections, this is more like, hey, you have a particular way you want the data, a particular physical thing you want to use, like maybe a particular set of Parquet files or a particular Apache Iceberg table that you created external to Dremio. So you created your own materialization, And then what you're doing is you're registering it with Dremio and saying, hey, Dremio, whenever this table gets queried, consider this extra thing that I created. So you can essentially create your materializations external to Dremio if you want, and register them with Dremio so that way it knows to consider them. That's what an external reflection is. Although, again, you can just, through a few clicks, just create them within the Dremio UI. Now, a really nice thing about reflections is that they can be created easily through, not only through the Dremio UI, but with SQL. And the cool thing about that is that SQL can be sent to Dremio not through just Dremio's user interface on the web, but you could also send SQL to Dremio via REST API, via Apache Aeroflight, via JDBC, ODBC. So you can automate a lot of this stuff. And a lot of people will do that. They'll create reflections and then they'll automate the, as new data sets or new whatnot, their pipelines automatically generate the reflections somewhere within their orchestration. And the SQL looks something like this. So if I were creating a raw reflection, I would just alter the table and say, hey, I want to take this table. I want to create a raw reflection on this table. I give the raw reflection a name. Although, again, I'm never directly requesting that. And then here in this case, I'm saying, hey, you know what? These are the columns that I want to materialize. And I want you to partition that particular particular materialization by country. So it'll be partitioned by country in this case. And then within the data files are sorted by the last name. So then you get basically that optimized physical copy that's sort of perfectly tuned to the particular queries I plan to be running against it. And with an aggregate reflection, I'd be saying here, like, create an aggregate reflection, in this case per state, and I'll say dimensions state. So basically, and then here I'm going to do measure city, count cities. So it'll be like the number. So basically things that will be inside the aggregation would be like the number of cities by state, because I'm only optimizing for the count measure of cities by state. So that physical copy will have that information in there, which would be, the number of cities by state. So I have all 50 states with the number of cities that they have. And I can name as many dimensions and measures as I want. And again, the other cool thing about this is that Dremio will allow you to set the cadence for when it updates it. So Dremio will handle the updating of these reflections. So unlike materialized views and cubes, where you'd have to go recreate them and manage recreating them or keeping them in sync, Dremio will just either kind of set it up to like once a day, once an hour, whatever cadence you want. It'll then go back and rebuild these. And there's some even better nuances to that I'll highlight later on. So this makes it, so the point is, this just makes accelerating your data, especially when you're working with data on your data lake, really easy. Okay, and that's the point. The idea is just to make having fast BI dashboards, fast reporting, really, really easy. Okay, by just taking what you've already built, the views, the modeling you've already built, and just saying, at a flip of a switch or a simple SQL statement saying, I want that to be faster. So again, in a raw reflection, I'm just taking an existing table or view. And again, just to give you some of the sort of the color or iconography in Dremio, whenever you see like a purple table, that generally represents like a physical table. So this is like the original files, like the original underlying table. These lightning bolts, they represent reflections. And then you'll see like green tables that generally represent views. So just so that way we all understand sort of like the iconography of it all. But you see in this situation, this table has like 45 other columns, okay? I don't need to materialize all 45 columns. So when I create my reflection, because I know the queries that are coming in are only asking for these 5 columns, okay? So I actually specify saying, hey, only display these 5 columns in the SQL. So now I have a materialization that doesn't have all these columns I don't need. Okay, it only has the columns I do need. And so those files are going to be a lot smaller, okay? Resulting in, and then I can have it add custom sorting and partitioning to that as well, and then have it really optimized for the particular queries that I'm expecting to be coming in. Okay, so it makes a lot of the engineering a lot simpler, because I just think about, hey, what is the version that I need? Then I can either design the reflection on it, or I can design a view and then reflect the view. Either way. And then Dremio will kind of handle syncing it and recreating it and keeping it up to date. So when you're creating a raw reflection, again, which is based on the raw data rows, you can choose which columns you're materializing, choose how the records are sorted, and how those records are partitioned. Okay, and that'll affect what the actual thing that gets created on your data lake. Now, aggregate reflections, which is the other category of reflections, here you get to choose two things. Which dimensions? Okay, so these would be the things that you would group by. Okay, so in this case, if I'm thinking like sales by department, I'd be like group by department. So those are your dimensions. And then your measures are the things you're counting. So this is what I put like, count sales, average sales in my SQL query. And essentially what it's going to do is then just basically create a table that's going to have all those measures all nice and organized for you and pre-calculated for you and then updated on a regular basis. So this way, when you're doing a BI dashboard, now when you flip that little switch and change, hey, I want to see it this city, or I want to change the different measures, it can recalculate it under a second because a lot of that's pre-calculated. Okay, so you see here, I might again have the table, but the reflection, the aggregate reflection, it doesn't show the columns, it's showing the measures that I'm capturing. So it's a table of all these pre-computed metrics. Okay, and again, sorted as an iceberg table, and again, the benefit of it being sorted as an iceberg table is that you're getting the best of a materialization and an index, because the metadata acts like an index, and then the physical data files act as a materialization, so you're kind of getting both for the price of one. So let's go over some like situations in which you might want to use a reflection. So in this first example, we're assuming that you have like a Postgres table, a Postgres database, a Mongo database, and a SQL Server database all connected to Dremio. Now by default, what's happening is that every time I query it with Dremio, there's an initial push down of the query being pushed down to the source system. So a query is going to end up being run by that Postgres server, or by that Mongo server, or by that SQL server, which is fine depending on what your needs are. But what if that Postgres server is also being used for other operational systems? Well, now I have analytical queries and operational queries hitting that server, and that just might be too, it might not be able to handle the load that's coming in. What I can do is I can offload it by turning on reflections. So by reflecting the tables and turning on reflections on the tables in these databases, what it's going to do is going to create that Apache Iceberg version of it on your data lake automatically. And again, you don't have to worry about how it does that or how often it updates that. It just works. And basically now every time I send the query to Dremio for that table that's in Postgres, so from the end user, they're just still querying the table in Postgres from Dremio, but behind the scenes, Dremio is actually substituting the reflection. So then you're not pushing down that query to Postgres, so you're offloading a lot of that work, which allows you to scale your databases even further. So you can still treat your database as your center of the world, but reflections will allow you to kind of scale that even further when you start hitting like the limits of like horizontal scaling with some of these systems. Okay, so that's one use case. Another use case is that you might have lots of data, whether it's on a data lake or a database, and you're federating queries between these different data sources, and you create a join. But again, if I don't reflect the join and it's a view, then what's going to happen is that it has to go get the data from each system and then recalculate the join and do that every time. I may not want to have to recalculate that every time someone hits this join. So what I may do is reflect the join. So now basically not the original table is being reflected, but the result of the join. And in that case, now anytime anyone needs the join data, they're going to hit the reflection and not push down queries to 3 different databases in this situation. Now, typically in Dremio, you do a lot of modeling right there virtually through views. Okay, so what they'll do is they'll connect their raw data, then they'll create a bunch of views that kind of model their silver layer with all their transformations and cleanup work, and then after that they'll do like their gold layer with all their business logic and metrics. And essentially, there's a couple different ways you could do it. You could do it like here, where in this case I am materializing the join, but notice, because Dremio semantic layer knows how each of these data sets relate to each other. Okay, it understands the lineage. It knows when I query these views that I've created, it can also use this reflection. It'll be like, hey, you're querying this. This is a child of this. This has a reflection on it. Is that reflection helpful for this particular query? If it is, it'll actually use it. So in this case, a reflection on this particular join benefits and can be used to accelerate queries on all of these views. Okay, resulting you in getting much more bang for your materialization dollar. So you're getting a much more reusable materialization and a much more effective materialization because, again, the additional index of the iceberg metadata. You can use it for accelerating BI dashboards. Okay, so in this case, we turn on an aggregate reflection on the view, and basically as people connect directly to Tableau, and like in the Dremio UI, there's literally a Tableau and a Power BI button to directly connect to Power BI and Tableau pretty easily. But Dremio also works for pretty much any BI tool pretty easily. I do a lot of blogs where we use Superset for different examples. And basically what happens is that when Dremio receives a query, it'll substitute the aggregate reflection, for a much faster BI experience. Probably one of the most popular use cases for Dremio. So there's a lot of other great features that exist for reflections. Okay, it's not just aggregate and raw reflections. In the last year, we've introduced incremental reflection updates. So before, what would happen is that when a reflection refreshed, it would rerun the underlying result. So basically, it would have to rebuild the thing, which is fine. But as you get bigger and bigger data sets, then that becomes a little trickier because it'll take some time to rebuild that reflection. But if the underlying raw data is an Apache Iceberg table, then the updates on the reflection are incremental because it can capture the change data or the delta between the different Iceberg snapshots and then translate that over to the reflection. So you get much more lightweight updates, and you basically your modeling, and then so basically this is assuming that you've created a bunch of views on top of the Iceberg tables, and then you're now reflecting that gold layer. Well, those reflections on that gold layer are going to update really fast, pretty much instantaneously, because of these incremental reflections. Dremio can pick up on, hey, these Iceberg tables were updated, and then any reflections built from those Iceberg tables can then incrementally update. Then there's a reflection recommender, okay, and that's one of the issues sometimes people have is okay, great, this is a cool feature, but when do I use it? Sometimes people might overuse it and reflect too many things, okay, so then you might reflect things that aren't really benefiting from it, and that doesn't necessarily help you, and whatnot. So basically the solution is we've created a feature to help you know when to use reflections. So now in a Dremio cluster, it'll actually monitor the type of queries that are coming in and give you recommendations on sort of what specific reflections will actually save you money and improve your performance, and actually also identify which ones you need to remove, which ones aren't helping you, and saying, hey, you can remove these reflections, and you don't necessarily, you can purge that data and save yourself that storage because you don't need those reflections. They're not helping you with the queries that are coming in. So the reflection recommender really can help you manage your reflections, so that way you just basically let us or let the Dremio platform tell you what needs to be done, and it'll give you the SQL to actually put it into action. There's reflection hints. This is more of a troubleshooting feature. Sometimes, maybe you just have a query that you don't want to use reflections for whatever reason. Okay, the reflections are there, but you don't want to use them. There's actually a reflection hints feature, so you can do things like disable reflections for a particular query, or point a query to a specific reflection that you want to use. But for some reason, maybe it's preferring another one. It's just basically, it gives you a little bit more granular control for those random situations. Reflection. Also, they've added the ability to set a schedule for when your refresh. You could already kind of set it before, but now there's specific SQL you can use to go refresh your reflections, so that way you can automate that process a little bit better. And then again, set the cadence, hey, does it refresh once a day? Does it refresh once an hour? Just a lot more SQL, a lot more ability to kind of granularly kind of control that directly. So, and there's a lot more coming in the world of reflections. It's a feature that's being heavily improved. And again, the eventual goal is just that it just kind of works. You just notice that your queries are just always fast, regardless, because the Dremio query engine will be aware of your query patterns and be able to kind of reflect and kind of take those steps automatically to improve your performance. Now, one thing is to hear me talk about it, another thing is to try it out. So I always recommend people try out the Dremio platform, get hands-on with it, so that way they can experience what these things that I am talking about. And this QR code here on the left is actually a great exercise that allows you to kind of spin up Dremio on your laptop with Nessie, make some Iceberg tables, actually see the files from those Iceberg tables on your data lake, because you'll be running a Minio data lake right off your laptop. and kind of just see that whole workflow directly from your laptop. And then like sort of like the next step from there would be to do one of these exercises that are like end to end. Essentially, these take you from a database, whether it's Postgres, SQL Server, MongoDB, take data from that a database, ingest it into Iceberg using Dremio, and then serve a BI dashboard with Apache Superset. So it takes you through that whole journey end to end, all from your laptop, so you can kind of see what that sort of life cycle would look like and that workflow would look like and feel like. And I'm constantly, not only talking myself, but also hosting others on a podcast that I do called Gnarly Data Waves. It's our like bi-weekly um, broadcast over there at Dremio, and you can subscribe to that on YouTube, Spotify, iTunes. So there's the information there. And again, I speak a lot of places. So generally, if you want to know if I'm in your area, you can join the Data Lakehouse Hub Slack community, and there you can find out, one, network with others within the Data Lakehouse community, but also if you join the meetup channel for your particular area, yeah, I'll make sure you're notified about, hey, when I'm in the area. And two, you can announce events that you organize as well. But here at those different areas, so there's like Meetup Orlando, Miami, all sorts of different meetups there. You can join that by scanning this QR code. And last, another way to kind of keep up with the events is subscribing to this calendar. So this is a calendar on Luma, and here I post all the events that I'm at. So you can just subscribe to the calendar and just get a feed like, okay, I'll be here, I'll be there, and to see, hey, if you find an event that you're particularly interested to hear more about Iceberg, to hear more about Dremio, to hear more about Nessie, and many of the other exciting things that I'll be talking about, and soon adding a couple new things to my repertoire of what I'll be talking about. So exciting announcements to come sooner than later. But yeah, that is the talk. So with that, what I'm going to do is I'm going to open it up to questions. So if anyone has a question, feel free to come off mute and ask away, and we'll do questions for a little bit. Oh, sure. Got it. Okay, I'll do that. I'll go to the Q&A thing. Let me just find it. Do, 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 do. Got it. Okay, done. So everyone should be. And again, if anyone has any questions, just come off mute and ask. Hey, Teresa. Sure. Sure. Let me just, I'm gonna unshare my screen so that way I can get the so I can go fetch the link. I'm gonna get the link for that main tutorial because that's gonna be the one that's really gonna be the one that's gonna make everything a lot clearer when you actually get hands on with it. So I'm ooh okay. So basically, like what a parquet file is, like you've first let's first let's ground level set. So probably you've probably worked with like CSV and JSON files in the past. Got it. Okay, so just to kind of like okay, got it. Okay, so got it. So basically, if we're working with like data in a database, what happens is that there comes a point where sometimes people want to, like, the database may not be able to fit everything or handle the particular scale of or type of work that needs to be done. So eventually what happens is that sometimes people will move to what's called a data lake. So they'll take like somewhere where you can store data, like an Amazon S3 or an ADLS. In this case, like in the tutorial, I'll use something called Minio. But essentially, it's like, think of it as like a hard drive. So all you're doing is you're saving files. Now, traditionally, the files that people use to store data is a CSV file, a comma separated values file, which is a file that essentially all the data is just text separated by commas. So each row, the first row has like the titles of each column, and then each one's a row. And then there's also JSON data files, which are basically more like semi-structured data. That one's a little bit easier to show, harder to explain, but it's essentially like it's like using a JavaScript based syntax for expressing data. And those are great. The problem is you have a couple different problems. Like those are text files. So they're literally just files with text in them that a program like Dremio is understanding. Because like Dremio can go into that data lake, go into that storage layer, and go read that CSV file or that JSON file and run SQL against it. So the same SQL you could run against a table in SQL Server, I can now run against these files. Now, the problem is like these files, when they get bigger and bigger and bigger, they tend to be slow. The reason is because text, there's like two layers. Essentially, if I'm looking at a text file, or if I'm thinking about the actual like underlying computer bytes, like first each bytes aren't telling me the data, they're telling me like T, O, M. So they're telling me like all these different letters. So first I gotta translate the letters, and then once I have all the letters, then I can translate the letters into data. So there's like this extra step, and it's also harder to compress. So the data files are actually bigger. So you have these two problems. It's encoding. Would be the term. So basically you have to first decode all the bytes based on the text encoding, and then apply like the logic for understanding CSV or JSON. So the point is like it's not as efficient. So someone said, hey, we need to make something better. So that's where Apache Parquet comes in. So Apache Parquet is just another way to store data in a file, but it's designed for analytics. So essentially, when you take a look inside a Parquet file, the data is set up in like columns, and instead of being encoded as text, it's using like custom binary encoding, which just means that you skip that whole like it can take the same amount of data and put it in a much smaller amount of space, because it's not like forced to think of it as a traditional text. So you're able to fit the same amount of data in a lot less space, but then what it does is that it breaks up the data into like chunks, so called row groups. So like maybe like the first 1,000 rows are one row group, then the second 1,000 rows are another row group, then the third 1,000 rows are another row group. So far so good? Okay, so now got it. Yes, I mean the APIs will. I'll have something separate to say about that, but yes. So now, so each row group in a Parquet file will have like a little bit of data attached to it. So also referred to as metadata, so data about the data. That allows you to know like, hey, even though I have 1,000 rows here, this column only has like the rate. There's like, let's say it's an age column. Well, this column only has ages 20. This row group only has ages 25 to 50. So now an engine like Dremio, if your query says, hey, find me anybody who's 60, it can know, oh, that row group doesn't have anything I need, so I can skip that group of rows. And that's how a Parquet file is set up. So it's so you can write big Parquet files like 1 gigabyte, sometimes multi-gigabyte, but you typically see like, gigabyte like Parquet files. And then, like if I have like a 10 gig data set, it's like 10 Parquet files or something like that. But generally, this is a way of putting data in a file. So in this case, it's independent of a database. It doesn't have to be in a database system like SQL Server or Postgres or Mongo. It's just a file that I can open when I want to using a tool like Dremio. And generally, pretty much any tool can read a Parquet file nowadays, as far as data warehousing type stuff. So that's what Parquet files are. The problem is, now when you're starting to talk about really giant data sets like petabytes, so let's see here, if we have 1,000 megabytes equals a gigabyte, and 1,000 gigabytes equals a terabyte, and 1,000 terabytes equals a petabyte, we're talking about like a lot of data. So when you're having data sets that big, they're not going to fit into one Parquet file. So now you have like thousands of Parquet files representing one table. The problem is there's not really a good way to know that those files are one table. So that's where Apache Iceberg comes in. Apache Iceberg is another layer of metadata you put on top that tells you, hey, these 1,000 files are one table. And that allows Dremio to interact with those 1,000 Parquet files as if they were a table in a database. And you can just, and so the experience from you as an end user is you're just interacting with a database table. Like you don't even realize that you're just interacting with a bunch of independent files outside of a particular database system. It just feels like a database. And that's the beauty of this whole what's called the data lake or data lake house, that you now have this way where you're separating the pieces that make a database work into separate pieces. So like Dremio is like the SQL layer, and then like S3 would be like the file storage layer, and then when they work together, it feels like you're using something like SQL Server. But it's not the, you can like mix and match kind of thing, like kind of piece together your own switch. You could maybe one day not want to use Dremio anymore. You can put something else that can also read Iceberg tables. Or one day, hey, I don't want to use S3 as my storage anymore. I'm going to go on-prem and use Minio. You can switch, and that's the beauty of that architecture, that you have that flexibility. But otherwise, you're still just querying data and running the same SQL as you would run in any system. Mm-hmm. Yep. Mm-hmm. Yeah. A 100%. Correct. That was a perfect. That was perfect. Like literally, you can the Dewey Decimal System is a perfect analogy for metadata, and the role of metadata. And then Dremio as a librarian makes a lot of sense. Dremio is going to go take a look at that metadata, and then be able to more quickly find the books that you're asking for. So that's a very, very, very well put. You know what? I might have to start using that. Mm-hmm. 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 Yep. And essentially all that still, when you're using a system like SQL Server, essentially all that is still happening. It's all abstracted away. Like it's just all one unified experience. The only difference is that a lakehouse, we're unboxing that experience into multiple pieces that you then assemble together. Mm-hmm. Perfect. I love it. I always love talking about this stuff. Um, I'll see. Does anybody else have any questions? Hey, Ed. Wait, was there a question? Oh, okay, good. Understood. Understood. Okay. Well, in that case, doesn't look there's any more questions. So I'm gonna wrap it up here. But I'm speaking all the time, so feel free to add me on LinkedIn. I'm always constantly talking about where I'll be talking next. And thank you all for attending, and thank you for all for sticking around with me these last 45 minutes. It was a pleasure. Always happy to educate, entertain, and enlighten, and it's been a delight. I'll see you all another time.